Thank you, Matt. I'm not sure about nationally renowned speaker. I don't think that applies to me. Let's see. Okay, so as Matt said, I'm with Britt Peters and Associates. We are a structural consulting firm. Our headquarters are in Greenville, South Carolina. We have 5 offices, mostly in the southeast, depending on how you want to classify Norfolk. So as of right now, I believe that have gone to construction documents, we've been involved with 43 mass timber projects. So how did we start mass timber, a smaller firm in Greenville, South Carolina? It pains me to say, Clemson University. So Clemson for the Southeast was at the forefront of research into mass timber through their forestry school and through their engineering school. So we recruit out of Clemson, and there's a lot of students coming to work that have done research in mass timber. So naturally, we pushed into the mass timber world, which includes, up to this point, I believe 4 projects at Clemson in varying capacities. So list is a little bit dated, but I would say the majority of our projects are, all of them I think are east of the Mississippi, 43 to construction documents, many more in design, and varying level degrees on all those. So when I put this together, I don't think Laura was scheduled to speak, so she did a much better job than I'm going to do. I'm not going to rehash what she just said. But so what is mass timber? She went through a long slide of that, and I may throw in some additional facts. So skip some of this. So right now, again, maybe a little dated. We tried to cover up or change some of the names, but for North America, these are the current mass timber manufacturers. So most are Pacific Northwest, East Coast, a lot fewer. Closest to here is SmartLam in Dothan, Alabama. It's now Mercer is in Arkansas, and then some up in Canada in the Northeast as well. So cross-laminated timber did a great job of explaining that. One benefit of CLT is the dimensional stability. So unlike NLT, DLT, we deal with it with stick framing. Is when I say dimensional stability, it means wood wants to shrink, especially perpendicular to its grain. So by alternating the layups, the panels do not shrink nearly as much as NLT or DLT. And you can see it in the detailing. You'll see with a NLT panel or DLT, there'll actually be gaps that are left for that shrinking and expansion that you don't get with CLT. So we can actually butt them up next to each other and create the joints. They're large panels, or they can be, so up to about 12 feet, and you said 60 feet. And it's not every manufacturer. I think SmartLam is right at 50 right now, maybe just over, depending on their plant. But you know, they're lifted large panels in place. NLT and DLT, I think we have one NLT project, and you know, a framer on site, you may not like the quality, but could put together NLT panels on site with a jig on the ground and lift them into place. We have one that we've done, and I'll go over it. Glue-lam and mass plywood. So I do think SmartLam has recently expanded their capabilities for their glue-lam, and they're looking at, or they were offering to price a project with the floor panels being glue-lam and not CLT, just to look at the cost difference, because they can be a lot deeper now. So now we'll jump into use in the Southeast. So I picked a handful of projects that we've done or been involved with in some capacity, just to show what is going on in this region. You know, Matt said we're lagging, but I think we're trying to quickly catch up. These projects date back to design probably around 2015-ish is about when we started in some of the design of these. And one of our first is going to be the Calvary Chapel in Chattanooga, Tennessee. So this project, 8,500 square feet, small footprint. The contractor owner, I want to say they had 3 to 4 people on site that were working on this. They wanted to keep the workforce small. And this was full CLT. Walls, floors, load-bearing CLT walls, everything. I do want to say there's 3 to 4 on site that erected this. So those glue lambs are actually non-load-bearing. They're for operable partitions. And the CLT actually just bears between the walls, the CLT walls. Beautiful building. This is a more finished look, topping slab. You know, those gaps on the side are for HVAC to run. We'll jump to a series of projects we have going up in Charlotte right now. So this is multiple phases. Right now there's 2 that have gone up. I think the second is going up right now. Multifamily mixed use. We do multifamily all over the Southeast, and these are unique because all the floors are CLT panels. They are not your typical 18-inch deep metal plated trusses with plywood. All of the floors are, I think they actually ended up being 3-ply CLT. Load-bearing walls, 2x6s, type 3. You can see the FRT exterior panels. The shafts are actually rated with char with CLT, so they didn't use what we would typically use masonry for those. One of the, with type 3, I don't know who's familiar with it, but especially with stick frame, becomes your exterior walls and getting those rated and FRT. So this was actually in Mecklenburg County, which is notorious for being the hardest to get code compliant type 3 construction through. And so can you put the CLT panels in the exterior wall or not is something you have to work through with your code officials, because CLT is not FRT. It is combustible. EchoStreet in Atlanta. So Britt Peters did not serve as EOR on this project. We were the mass timber engineer. I believe we worked with Smart Lamb, panel design, connection design of the panels. Again, a beautiful hybrid building, and I think I have another hybrid building coming up after this, but it's one of the areas where I see CLT and mass timber being able to push into the market quicker than the full mass timber building. And you can see here the openings in steel beams for HVAC. And this is a similar building we did this is in Columbia, South Carolina. So this is Bull Street. Again, this is a hybrid structure, steel frame, CLT floor panels. And I see it competing because of the price. I mean, it's the cost of this compared to a full mass timber building is a lot more price competitive that we've seen. So again, the steel is, for this type, is unrated. So when we start talking construction types, you have to start thinking about fire ratings. And I don't know if contractors have ever priced intumescent paint. You don't want to do that. You're not going to be price competitive. You don't want to spray fireproof all these beams either. So it needs to be a construction type that allows an unrated primary frame. This in the end ended up black matte paint. You can see the connections from the CLT to the steel, fairly minimal screws. This one we actually had shafts that were CLT as well. Brookhaven City Hall in Atlanta. This is one of mine. It is a It's almost full mass timber. There are some hybrid elements. The shafts are cast in place concrete. There were some longer spans. There's actually a big dome that is going on top that had to have some transfers that we had to work out. The roof here is going to be a green roof. The renderings have some fairly large trees on the roof. We'll see how they grow. But this was all 1 hour rated construction. And so the detailing of getting that 1 hour is always, I would say, a detailing challenge we need to work through. So this is Continuum. This is actually an old Walmart. Florence Darlington Technical College. We did a remodel of an old Walmart to turn into part of their technical school. This one is NLT. The glulam beams and columns. Most of the mass timber is going to be that entry piece. It actually extends the full depth of this building. We had to do a lot of seismic upfits throughout the structure and wind upfits, but adaptive reuse, we use mass timber here. And you can just see the connections, beautiful connections if you want. A lot of times when we're exterior or even interior, the columns you don't want touching the ground for water purposes, so everything's lifted off the ground here. This is at Wofford, so this is their environmental science building. This one, 2018, 2019, so fairly old at this point. This was almost a full mass timber building as well, except for some of the shafts. And this one, the geometry was fairly complicated. And so you can do a lot with mass timber. And this had floor plates didn't align, double cantilevers on corners, a lot of utility line runs to work through. We actually, above the second floor, it's a lot of masonry veneer on this building as well, and supporting that off mass timber isn't always the simplest feat, especially considering long-term reflections of wood versus steel. So this is a more complete construction of this. Again, you can see the cantilevers and the bearing, the way we handled that at the columns. CLT floor plates, and this is where we overframed overgirders for utility line runs. You can see that throughout the second floor here. Another university project. This one's been on pictures of a lot of magazines or websites. So this is the Andy Quattlebaum Outdoor Education Center at Clemson. It's a hybrid construction, but it's steel columns, glulam beams, CLT roof panels. I believe this was the first Southern Yellow Pine CLT building east of the Mississippi. Elevator shaft CLT on this one, again, char rating as needed for the shafts. And I don't believe that's codified. I do think you need a exception from the building official to do shafts out of CLT. But beautiful building. You can see a lot of this timber is, so this is Southern Pine, and it is not pressure treated. It is exterior. It is not subject to being wet, constant rain. It's on the underside, the soffits. You can see we actually held the beams back from the overhangs to mitigate the water and capped the ends of, you can see we capped the ends of the glulam to keep the ends from absorbing water. if you go and look at it, there will be a color difference between exterior and interior just from UV. So it's something that I don't know if there's a solution to it, but it doesn't take away from the beauty. But if you do go see it, that is why. So we can, again, a lot of exterior timber here. Again, none of it is pressure treated. It's all, we held it back from rain, and we wanted to be sure it had the ability to dry out. That's the biggest thing. I do think Clemson's doing some research where they have CLT panels just sitting outside to see what happens. And I think they may have been there 5+ years, and there's structurally they haven't noticed much. The big thing is you have to make sure it can dry. So this one, structurally, we actually used moment frames that were built out of steel columns and glue-lam beams for this one. There's operable partition again where we, the track is inserted into the glue-lam beam for that space. Heyday Market at Auburn University. So this is part of their, like, I don't want to say culinary program, but it's essentially a food court. And we were consulting engineers on this. There are multiple phases or pieces of this project. We worked on the mass timber piece. And so this one, actually, the concrete bases on this were precast concrete pieces to hold the columns up, and glue-lam beams, glue-lam columns, CLT deck. And this is Samuel Caden Chapel at Clemson, another Clemson project. Heavy timber, trusses, and CLT. Actually, the walls are wrapped. You can't even see the CLT. They're wrapped, but structurally they're utilized on this project. This is over a basement. So structural engineering, I wanted to touch on some design challenges and benefits we see with mass timber. So as Matt said, I'm hesitant to say it, material agnostic. I design with all types of material. And so why do we use mass timber? And the reason to me is I think it looks good. Like, it's hard for me to convince an architect to let my steel beam be seen, but you're fighting the opposite battle with timber. Everyone wants it because of the look. I haven't met a developer or an architect that does not want to use it. And so I guess some scientists had to get together and explain that phenomena. And so this is a study, and it's touched on in biophilic design, but what is it? And so this was a study done with work experience versus amount of exposed natural looking wood in the building. And so you can see the more wood you're exposed to, the better working experience you have. And again, biophilic design, it integrates nature into the built environment, an approach to architecture and interior design that is becoming more common due to its positive impacts on occupants, particularly indoor workers, through a connection with natural elements. And Laura also mentioned the rental rates or lease rates and occupancy amounts using timber. So why? The other why would be sustainability. So there's actually Samuel Caden Chapel. That's the finished product. And sustainability, I think it's hard to argue against it. So it's lower embodied carbon, fewer greenhouse gases, continual carbon storage for the life of the building. And we did a life cycle analysis. So this is a building we have going up. It's not in the south, it's at Western Michigan University. It is a load-bearing, it's a dormitory, load-bearing, light gauge, cold form steel building. The floor plates are CLT. We did a study versus, I would say, a more traditional hollow core plank flooring. And so this is cradle to gate, which is not cradle to grave. There's not an end of life in this. We didn't check foundations. We didn't check transportations. We said all that is equal, and essentially because we didn't know what the end of life was, and we didn't redo the foundation design. So there would be more foundations. But so there's a 30 to 60% reduction in carbon when you go to CLT for this particular building. And 60% is if we consider the carbon sequestration, which would more consider the end of life, as in, that building is holding the carbon, versus if we didn't consider it, it's still a 30% reduction versus the hollow core plank option. So design challenges, I think Laura touched on some of these with the construction types. So the first thing as a designer, these are the mass timber suppliers in North America. The European map's bigger. When we get on the front end of a project, we're not selecting this. The owner, the contractor is. So if we get on a project to design it, and there's not a contractor involved, and it goes to bid, who picks who's supplying it? The difficult part is every one of these produces different size glue lambs, different size CLT, wood grades are different, char ratings are different. What connection types are they going to use? So it's a challenge we work through on every project. It's a challenge best handled by knowing who is having a timber supplier on board early. And that usually requires a contractor being on board early, or at least see them at risk for design build. We have fallen into having to design a building more than once because we design it to one supplier, we're working with that supplier, pricing comes back better from another supplier, and so we're just going to switch. And it's not easy to deal with that. Two, your design team and the level of detail at which they are modeling all of their elements. And so, and then who in the end is in charge of modeling all the elements? Is it the design team that puts in all the plumbing lines, or is it the contractor sub who needs to create their own models that then get shared with the timber suppliers? This is Brookhaven City Hall. It's just a CLT shop drawing. This building has actually had access panel floors, so the MEP, which, basically all the utilities were between the access floor and the top of the CLT. So underneath, you didn't see duct runs, you didn't see plumbing lines, you didn't see electrical, and the slab penetrations had to come through. But when we're reviewing shop drawings at that early stage, those openings need to be in the panels or the beams in the shop and not in the field. With a concrete slab on metal deck, we don't see any penetrations on the shop drawing. They put them in the field, and we have some typical details to put some extra rebar around it, and they go. So making sure everything is coordinated prior to getting this stuff to the field is vital. Laura again talked about construction types. I won't dive into it too much, except to add You know, Georgia's adopted Type 4, which is great. All the high or tall Type 4 provisions. Not one structure I showed was Type 4 construction. They're all Type 3 or Type 5. So just because Type 4 is there, I think if you're an architect, you need to know all the requirements of Type 4 beyond just this. Historically, we've always kind of been in that Type 3 or Type 5 construction. I just want to point out, you know, we're talking about fire ratings. I don't know if there's a, I'll probably cut it off. I'll try to use this. No. The primary structure, so it has a 1, a 3, 2, 2, 1. So those are all your fire ratings. I will say, if you're looking to get, if you're dipping your toes into the mass timber world, when you see the price difference of a 0 and a 1, I think it can be a little eye-opening. So you need to be, I don't know everyone's budget, but when we see clients saying, oh yeah, let's look at mass timber for this, and then they're Type 3A, you know, we kind of know that's a sign that it's probably not going to happen. So, you know, the architects and your designers, the way your building footprint and your heights and all of these things play into like where you can classify your building. So trying to get it to fall into one of those with a 0 or even the HT is always cost effective. It can be done, and mass timber, you know, here does have a char rating, and we can get a fire rating with it. But again, it's an added material. So you design it, and then you just increase your piece sizes to get there, and you have to conceal all your connections. So anyway, so there's additional resources. So Woodworks, great, Laura's here. AWC, Clemson, again, has done a lot of research. But I just want to thank everybody for having me. Any questions?